Hello judges, my name is Sheryl Hsu, and my project is titled Explore and Fuse, a Physarum-Inspired approach to the Steiner tree problem. Explore and Fuse is a novel approach to solving difficult problems. It's inspired by Physarum polycephalum, which is a unicellular neon green slime mold capable of solving the Steiner tree and traveling salesman problems. In addition, Physarum organisms can share information with other Physarum organisms through fusion. These unique characteristics of Physarum inspire us to create the Explore and Fuse approach, where we spawn many computational models of Physarum. Each individual organism can then gather local information and form partial solutions. As these organisms explore, they meet and fuse, sharing information. Eventually, all these individual organisms fuse into one large Physarum organism, which can then solve the overall global problem, taking into account information gathered by each of the individual organisms. This approach thus presents a balance between speed and optimality. We now demonstrate the Explore and Fuse approach on the Euclidean Steiner tree problem, creating the Physarum-Steiner algorithm. So essentially what we want to do is find the minimal length of the tree that connects all of the gray squares. We begin by spawning 100 Physarum organisms. Each individual organism moves around and finds squares close to it. As these organisms explore, they come into contact with nearby fellow organisms and begin to fuse, forming larger and larger organisms. Eventually, all the organisms fuse into one large organism that contains all of the desired gray squares. This large organism can then globally solve the Steiner tree problem, taking into account information gathered by each individual organism. Some noteworthy properties of the Physarum-Steiner algorithm include its ability to leverage parallel processing, form Steiner trees around obstacles, form networks with various levels of redundancy, and operate on various topological surfaces.